Good morning, student of class 12. I hope you are well at home. And in previous class, we have finished alternating current, and in that class, our last topic was transformer. And you have seen there are two types of transformer, step up and step down. And today, I am going to start a new chapter, electromagnetic wave. After the discovery of electromagnetic induction, it was clear that magnetic field and electric field are dependent. Before the discovery of AMI, scientists think that electric field and magnetic field are independent. Electric current can produce magnetic field, and a variable magnetic field can produce a electric field. Maxwell noticed that a variable magnetic field can produce an electric field, and a variable electric field surely will produce a magnetic field. And the displacement current hypothesis come in the new source of magnetic field. Then Maxwell established the relation between magnetic and electric field by four equations. And these equations are called Maxwell equation. And the first one, displacement current. When a capacitor is charged, then electric field is produced due to flow of current inside it. Means between the two plate of capacitor will produce an electric field, and this current is called displacement current, and it is given by ID equals epsilon 0 d phi upon dt. And the basic idea of displacement current given by Ampere but modified by Maxwell. Ampere's circuital law for conduction current during a charging of capacitor was found to be inconsistent. Therefore, Maxwell modified Ampere's circuital law by introducing displacement current. Maxwell equations. Maxwell equations are the basic laws of electricity and magnetism. First one equation, Gauss's law in electrostatics. According to the Gauss's law, the total electric flux through any closed surface is always equal to 1 upon epsilon 0 times the net charge enclosed by the surface. Then in mathematical form it will be integration of surface E into ds equals q upon epsilon 0. This is the first equation of Maxwell. Second, Gauss's law in magnetostatics. The net magnetic flux through any closed surface is always 0. It means integration B into ds equals 0, where B is magnetic field and ds is surface area of the system. Faraday's law of EMI. The induced EMF produced in a circuit is numerically equal to the rate of change of magnetic flux through it. Integration E into di equals minus d phi v upon dt. This is the third equation of Maxwell. Ampere's Maxwell circuital law. According to this law, the line integral of the magnetic field along a closed path is equal to mu 0 times the total current threading the surface bounded by the closed path. Integration of b into di equals mu 0 ic plus id. This is equation number 4, where id is displacement current. Next, electromagnetic waves. Electromagnetic waves produced due to change in electric field and magnetic field sinusoidally and propagates through space such that the two fields are perpendicular to each other and also to the direction of wave propagation. And source of electromagnetic waves: oscillating charges produce electromagnetic waves. Electromagnetic waves are transverse in nature. Important characteristics of electromagnetic waves. First one, electromagnetic waves are produced by oscillated charge. These waves do not require any material medium for propagation. Third one, these waves travel in free space with the speed of light 3 into 10 to the power 8 meter per second. And C we can calculate by C equals 1 upon under root mu 0 into epsilon 0. This shows that light waves are electromagnetic wave in nature. And speed of electromagnetic wave in a medium is given by V equals 1 upon root mu epsilon. Next, the direction of variation of electric and magnetic field are perpendicular to each other and also perpendicular to the direction of wave propagation. In free space, the magnitude of electric and magnetic field in electromagnetic waves are related by E0 upon B0 equals C. The energy density in an electric field in vacuum is 1 upon 2 epsilon 0 E square, and that in magnetic field is B equals V square upon 2 mu 0. And energy associated with an electromagnetic waves U equals 1 by 2 epsilon 0 E square plus 1 by 2 B square mu 0. Radio. Next one, radio waves. These are produced due to oscillating charged particles and the frequency varies from 500 kHz to 1000 MHz. Microwaves. These waves are called short wavelength radio waves, which are produced by vacuum tubes, and their frequency lies in the range of 1 GHz to 300 GHz. And some uses of microwaves are: these are used in radar system for aircraft and navigation. Second, these are used in microwave oven for cooking purpose. Third one, these are used in study of atomic and molecular structure. Next, these are used to measure the speed of vehicle, speed of cricket ball. Next, infrared waves. These waves were discovered by Herschel. These waves are also called heat waves. These waves are produced from the heat radiating bodies and molecules. And infrared waves have high penetration power. Its frequency ranges from 3 into 10 to the power 11 hertz to 4 into 10 to the power 14 hertz. And some uses of infrared waves are: first one, these are used in physical therapy. Second, these are used in satellite for army purpose. Next, these are used in weather forecasting. These are used for producing dehydrated fruits. These are used in solar water heater and solar cells and cooker. Next, visible rays. It is that part of spectrum which is visible by human eye, and its frequency ranges from 4 into 10 to the power 4 Hz to 7 into 10 to the power 14 Hz. Visible rays are used by the optical organs of human and animals for three primary purposes given below: to see things, avoid bumping from them and escape danger. Second, to find stuff to eat, and to find other living things with which to consult so as to prolong the species. Uses of ultraviolet rays. These are used in burglar alarm. These are used in checking mineral sample, to kill germs in minerals, and to sterilize surgical instruments. X-rays. These rays were discovered by German professor Ronnegatten. Its frequency range is from 3 into 10 to the power 16 Hz to 3 into 10 to the power 21 Hz. Use of X-rays as given below. These are used in surgery to detect the fracture, diseased organs, stones in the body. These are used at metro station to detect metal or explosive material. These are used in scientific researches. Gamma rays. These rays were discovered by Rutherford. They travel with the speed of light and having high penetration power. And the frequency range of gamma rays 3 into 10 to the power 18 Hz to 5 into 10 to the power 22 Hz. And uses of gamma rays are: these are used to produce nuclear reaction. These are used in radiotherapy for the treatment of tumor and cancer. These are used to provide valuable information about the structure of atomic nucleus.